Hi guys, it's Mrs. Deming. I don't know if can I show you myself with this? I'm going to be upside down, but that's still me. Hello, it's my house. I'm going to do an experiment with you guys today where we look at the effect that abrasion has on the sediments that are being transported in a stream. So you saw in that video that I posted that the sediments are not just nicely going down the stream, that they're rolling and bouncing and going up and then settling back down, and all that leads to all these collisions between the sediments. And now we're going to look at what do all those collisions do to the sediments that are being transported down the stream. So this is that kind of area where weathering is the breakdown of rocks, erosion is the movement or transport of those sediments, those rocks. So here we can see that it's very hard to separate weathering and erosion. We're looking at the weathering piece of it, but in order to have the weathering, we need the transport, the erosion. So we're focusing more on the weathering today, but it's in a system that is also eroding. So I'm going to show you some of the stuff I have. Let me flip you guys back around and make sure that we're lined up. So I have my equipment all laid out. I've got my strainer. I put a coffee filter in there. You want a strainer with pretty small holes, not something large like this, because some of your stuff will go right through it. You can put a coffee filter in something like this. I've selected out of my pile of goodies here, I collected a whole bunch of stuff. You could look around your house. We want something to model different rocks with different composition. I've chosen some actual rocks. These are those nice angular rocks. We talked about how they just fell off a cliff. I actually got these from a cliff that was over a stream. So these were just about to fall into a stream. So I had that. And since that's what we're doing today, we're modeling a rock that first falls into the stream, then tumbles down. What was it going to look like when we pull it out, years later, thousands of years, 10 years, like how long? We're not really looking at how long this takes, but like what happens to a rock that spends some time in these abrasional systems. We're going to be modeling a stream, but this would be similar to also a glacier that's like carrying rocks on the bottom and grinding them along, or wind, where mostly sand particles are blown in the wind, but the effect is the same. So I have some angular rock pieces. You can go out in your yard and find little bits along the side of the road. Make sure you have a parent with you, that your road isn't busy. Little bits. Angular is better, but whatever you've got, as long as they're different. The two that I chose are the same type of rock. You don't have to have two. You could just have your 1, 2, 3 like that. I happen to have double of each. I'm using some of my daughter's sidewalk chalk. I have a large candy cane that I smashed up, but you could use a lollipop, bracelet, candy bracelet, jelly beans, chocolate, whatever you got. You want 3 different materials that are going to break down in water, and that you have permission to use for this. I'm going to take a picture of what they look like when they first go into our system. So I'm just going to take their picture now, have it. I had my hammer here because this is what I used to break up the stuff. If you break it up, you don't have to use a hammer. You could use anything solid. You could kind of crush it, grind it. While doing that, though, make sure you put on some sunglasses just to make sure you don't get anything in your eyes. Tums, I didn't have it in the picture, but because I don't have any, but like a bath bomb or something chalky and kind of hard, but that will break down, might work as well. Sugar cubes, we also didn't have those, or large salt crystals that you put into your grinder. Salt grinder, if you have those. Or this time of year, you can still, especially since we've been getting snow, you can still find large, very large salt crystals along the side of the road that would work really great for this. So you just need at least 3 different materials, 1 piece of each. I happen to have 2, so I'm going with the 2 pieces. I'd like you guys to try this. If you don't try it, then you can just watch my video, and that will be enough. Okay, so I'm going to put some water into my container. Make sure the container is something that you are allowed to use, and that if something happens to it, no one's going to be upset that you ruined their container. I'm just looking at this. I think I want a different container. I want something else. Okay, so I switched something a little bit larger so that the samples actually had a chance to move around in there. So we're noticing that we put them in, that they're kind of angular because I broke them with the hammer. And we're going to plop them in the water. Oh, look, the chalk kind of is already like fizzing a little bit and it floated. It's interesting. And then we're going to just give it a shake. Okay, your container, depending on how tight it is, might leak, so you might want something, or you might want to lay a paper towel over the top of it, or a towel. You want to shake it for a good amount of time. I'm going to pause it while I'm doing this because you guys don't need to watch me shaking it. Okay, guys, so I've been shaking this for about 3 or 4 minutes. We can see right there, there's some evidence that those samples are starting to break down, and maybe even which one was breaking down the fastest. I'm going to drain these so that we can take a look at the pieces that are left. I'm going to take this over to my sink. If your parents are concerned with stuff going down the sink, just go outside and dump this, or dump it into another container instead of down the sink. Okay, so I have these in my strainer. I actually took the coffee filter out. It was taking a really long time, so I'm going to dump these on here. And we can see a couple of things. I'm going to put these back in order so you can compare them to the picture here that's right next to it, of what we started with. Can't get them exactly lined up how they were, but they were something like this. Oh, this guy really had a traumatic experience. And we can see that it took an original sample and broke it into smaller pieces. We know what that does now to the surface area and how weathering from here on out is going to be faster because of what happened here. So we're looking at what has happened to the size and shape. So we're looking at this one, comparing it here to what we have now. It has, the color is, it's not really becoming round, which is what I thought it would do, because the candy has some weird textures to it. But it is losing some of those sharp corners, and some of the mass is falling away. It's probably dissolves because sugar is soluble in water, so it probably dissolved into the water, became ions, which are sediments as well. This chalk shows it the best, though. We've lost mass, they've become smaller and more rounded from all those collisions. And this guy definitely shows how they become smaller. That blueness to the water was all the parts of the chalk kind of getting turned up in there, little teeny tiny sediments, very small ions. Okay, so we could do this again for several minutes. At this point, I would want you to take a picture again as evidence of what's happening in your experiment, so that you could use it to do a little write-up if you wanted to. Okay, so we can see right away what happened to the size and shape. One thing to think about, and we didn't shake it long enough for it to really be evident here, but these little corners that stick out on an angular piece, the sharp corners, they are the most vulnerable. So the corners get knocked off first, what starts us down that path towards a rounded shape. The corners go first, and then once it becomes rounded, it actually slows down a little bit in the weathering because these things come off very quickly and first because they're very vulnerable. Then when it's more of a rounded shape, doesn't have all those little vulnerable corners sticking out. I just thought of something I wanted to share with you, and I think that's it. Oh, so we're going to look at this. It's going to ask you a little bit about which one of these is most resistant, which one of them is least resistant, which one is most competent and least competent. The word competent means able to withstand weathering. So one of these was more able to withstand weathering than the others. We have our rock, our candy cane, and our blue chalk. Resistant, same thing, able to withstand the weathering, doesn't weather as quickly. The rate would be slower. So you can kind of think of that as with our results here, which one was the most resistant, which one would be the most competent. They would be the same. I hope you guys try this on your own. Just send me a quick little, write up saying you did it. If it doesn't have any images or anything in it, just have your parents email me as well, and we'll give you some extra credit. Hope you have fun trying this out.